Good morning. How are you all doing today? Another Monday. 2 more Mondays and we're done. 2 more Mondays. We're done. Do you ladies have any questions for me? Let me see the chat. Oh, when's the next third exam? Oh, good question. We should finish 7 today, so I will probably have the test available by tonight, and I'll give you guys a week to work on it. So it'll be due on Monday, and I'm gonna do a little bit something different. I'm going to make a video, and I'm gonna tell you exactly where to find, like, which sections to look for those particular problems. It's not gonna be like a review like I did for number 2. It's gonna be a little bit different, where I'll tell you which sections to look at to do those certain problems. And it's in order, of course. It'll be chapter 6, chapter 7. So yeah, I should have it available by tonight. So you'll have a week to do it. So yeah, because next week's already finals, right? Finals. So we only need 3 more chapters. We need 7, 8, and 10. So today we're gonna do 7. 7's easy. It's another easy one where you just plug it into Statdisk and it'll calculate the formulas for you. I'm gonna share on the chat the notes for 7. I should have done it last night, but here's the Statdisk notes for 7. I'm gonna put in the chat. Y'all can keep it and print it out if you want. They're also available. Don't forget, they're also available on our Canvas page. If you go to modules, you scroll down, there should be an icon that has notes for Statdisk. They're all there, all of them. You can print it whenever you want. So there's that. And we're gonna do 7. Do y'all have questions for me? You ladies, all right? You excited about next week? Next week that's it? Done. Right, next week. Then you can go have your margaritas or whatever. Or juicy juice if you're not of that age. Or yeah. Have your parents sign. Okay, all right. So it starts to seem interesting, the material that we covered, because you do see it, the process at work when we talk about it's called estimating a population proportion. Right. So the title of it is it gives it away, right? So we're talking about a population, right? So let's say that you want to sample, you want to collect information from the city of San Antonio, whether they agree on raising sales taxes to, I don't know, make a railway system that goes from here to Austin or whatever, right? So yeah, you have to, well, of course, you're gonna have to deal with the whole entire population. I don't know how many people live in San Antonio. I think it's like 2 million or something like that. 2 million or 3 million. I don't know how many people, but you would have to collect that amount of data from San Antonio. 3 million, 2 million. That's a lot. Right? I don't think you have time to do that in 1 year just to go and get that sample, right? So you can't. It's going to be hard to do. I mean, you can do it, but it's difficult to get everyone to participate in that survey, right? So what we do is, instead of going out and collecting all of the information from the entire population of San Antonio, we estimate it. And there's a way that you can estimate it. You can just sample a portion of the population. And so using that sample can give us a rough estimate of what the whole population is thinking. And that's how the process of the voting works. When you guys go vote, right? You vote for, I don't know, an elected official, right? Whether it's president, governor, representative, senator, whatever, right? And you see on TV how the TV stations get the results quick, yet they haven't counted all the votes. I mean, it takes a long time to count. I don't know how many billion people that live in the United States, right, to get the results that quick. So what the news stations do is they estimate it. They get a sample from a precinct that's, it's known to have good voter turnout. They use that to project what the population is voting for, and that's how we're going to be doing this. So one of the things that we need to look at first is this term proportion. What does proportion mean? Well, a proportion could be a percentage, it could be a fraction, or it could be a decimal. It could be any of those. So if you think of percentage wise, it could be what, 40%. You know how to write 40% as a fraction? 40% would be what would that be? That would be what, 40%. What is 40% change? Well, I guess you would write it as 40 over 100 and then reduce it. 4/10. What is 4/10 reduced to? That would be 2/5. Right? So 40% is really 2/5. And if you want to change 40% to decimal, right, you just divide 40 by 100, you get 0.4. Oh. So that's what we're going to be estimating. We want to get the percentage. We want to get the percentage. We want to get a fraction. We want to get a decimal of the total population of whatever survey you're doing, and we're going to be estimating it. Again, it's you're going to be using a sample to determine the overall estimate of the population. So that's what we'll be doing. All right, so there's your proportion. That's what a proportion is. It's one of those. So you'll see all the problems that we deal with in this section are going to be either in percent, but usually it's a percentage. It's either you're in percentage or it's in decimal. But if you ever see it in fraction format, just convert it. Divide 2 by 5, so you get your decimal. That's what we're going to be doing today. So a couple of terminology terms that we're going to go through that's important. I'm going to put definition, the definition. First definition, it's a lot of we're going to be doing a lot of terms and notation and all that stuff, and then we'll get to the bread and butter of this section. It's in the formulas, but just bear with me with the terms and the definitions. All right, so the first one is called a point estimate. Okay, a point estimate is a single value used to estimate a population parameter. I call it parameter. Parameter. In the book, it says, okay, so here's some notation that you're gonna have to just keep in mind. Keep it in your mind. The sample proportion, which we use a P with a sombrero. It's a little hat. P hat. That's what a sample proportion is written as. It's a small P with a hat. They say that is the best point estimate of the population proportion. And they use the symbol regular P to notate population proportion. So sample proportion is P hat, population proportion is P. The sample proportion, I'm going to give you the formula for it, because they're going to ask you, what's the best point estimate? So the best point estimate formula, best point estimate formula is P hat equals, just like we did with the probability, it's parts over total. So your X over N, where X is the part, N is the total. Part, this is total. And that's the formula for it. So anytime you all see that word, best point estimate, that's the formula that you're going to be using. Oh, and don't round it. Do not round. Okay, don't round it. In the handout that I sent out to y'all in the chat, oh, some of y'all came in late. I have to resend it. Somebody that came in late. It's in the first page. I'm going to show you in a minute. Let me send it again, because some of y'all came in late. Well, send it. Where is it at? There you go. I must resend it. Some of y'all came in late. It has it on that handout that I gave y'all or sent y'all. Let me open it up so y'all can see it. All right. So first page of that handout I gave y'all, the very first page gives you the formulas if you want to do everything by hand. You don't want to do Statdisk. You want to do everything by hand. There it is. You can do it by hand if you want. Good luck. Manually. I hope I spell manual correctly. Right. There is a formula right there that I was telling y'all. The best point estimate formula. There it is. Boom. Right here. I can't move the freaking cursor. Right there. There's the formula right there. Should have it highlighted. Where's my highlighter? Comment. There is the point. There is the best point estimate formula. Boom, right there. That's the one that we just went through. And pretty much the whole front page gives you the long way of computing the things that we're going to be doing in here, right? The next few pages are going to show you how to do it via Statdisk, where you don't have to plug in anything into the formula. Maybe the last one you will have to do the formula, but the other stuff you won't have to do. So then it gives you directions on how to utilize Statdisk, all the steps. Like where you go to analysis, confidence interval, proportion, one sample, and I put all the little things that you have to enter, and then I circled all of the things that you're going to look for and word around. Okay, and I have it for every part of each section. And I showed you all where not to plug in numbers, and I blocked it off, so y'all can see where do you plug in and which blocks you don't enter. If you have a graphing calculator, it also shows you how to do it using your graphing calculator. So if you have a graphing calculator, it can also do it. And I gave you the steps on how to do, how to use your TI 84 or 83, whatever. It shows you how to do it. And I did it for each section. So if you want to do it, if you want to do this section the long way, you want to do it with Statdisk, or you want to do it with a calculator, it's totally up to you all how to do it. The only issue is the rounding part. So you got to use this paper. You got to use this handout to know where to round, because I labeled everything in this chart, this handout. Okay, it's all there. So you can't lose. You just refer to this handout to know your rounding rules. Okay, don't forget. It's all in there. All the notes. All of them are all in there. All of the steps and all that. It's all there. So I'm gonna go back to this. I'm gonna go back to this handout in a little bit. So that's what we're gonna be doing. So I know a lot of this stuff that you're like, what the heck is this stuff? Well, again, I have to go through all the terms first, and then I'll show you all what the meaning behind these things. Okay, I'll show you. So don't worry, it's a lot of blah 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 today. A lot of blah 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 at the beginning, and then I'll show y'all. Okay, so let me go back to my notitas. Okay, so there's your best point estimate formula. The next definition, right? So what we're going to do, I'm going to show y'all kind of an example of what's happening. Okay, so let's say that you're going to I forgot when we're voting. When are we voting for the governor? I think it's November, right? I don't remember. Well, anyways, let's say that you're voting. You're going to vote for a candidate. Voting for a candidate. For office. Right. And you have candidate A, candidate. Let's see.
Can I see the?
A and candidate B. I was gonna put names on them, but I don't know who was gonna run for governor. I was gonna put Willie Nelson. Willie Nelson, and who else could run for governor? Willie Nelson and
Thank you.
Willie Nelson, and who's another Texan that we could? What famous Texan would you vote for besides Willie Nelson? I don't know. Tim Duncan. I don't know. Anyways, you have your two candidates, right? And you're running. And let's say that this is 40%. Candidate A has 40%, and candidate B has 60%. Right. Right. And so you have these projected, right? They're coming in on TV that it's displaying that candidate A has 40%, candidate B has 60%. So how do they calculate these numbers so quick? Well, what they do is, if you look in the bottom of the screen on TV, on the TV, when they have these projections on there, it's really tiny fine print, really small. You see this thing called margin of error. And usually it has plus or minus 0.5 or something, 0.05, something like that. It's something like that. 0.05, something like that. Really small, really small. So they use this margin of error in order for them to compute a estimated projected winner. That's what they use. They use this margin of error to come up with these numbers, right? These numbers, margin of error. So that's what we're going to be using in order for us to get these numbers so quick. So before we do jump into the margin of error, there's other things that you need to know before well, that number right here, that number, you need to know what the heck is that number. So they talk about what we call confidence intervals. There's another definition. Confidence interval. Okay, that's going to be something that you guys are going to be using in here. All right, so confidence intervals. What is a confidence interval? A confidence intervals are a range, is a range of a range used to estimate the true value of a population parameter. All right, population parameter. That's what a confidence interval looks like. So we'll do an example here. All right. So I'm gonna show you what a confidence interval looks like. Let me try to think. Okay, I got one. At what age did you take your first, at what age did you drink your first alcoholic beverage? Okay. Natalie, how old were you when you first drank your first alcoholic beverage? 18, all right. Victoria, how old were you when you first took your first?
Is it judgment-free zone? Just kidding. My brother or my sister made me try it at 14, but it was just a sip of beer. That's all. I swear.
All right. Hey, we're not judging, ma'am. We're not judging. I'm gonna tell your mom. I'm kidding. Desiree?
She's in the other room. It's okay.
Oh, all right. Oh, does she have the chancla ready to go?
Yeah.
Yeah. Desiree, how old were you when you first had your alcoholic beverage?
15.
15. We're not judging, man. Okay. Right, legacy. Woo! I'm kidding. Enriqueta, how old were you when you first had your first drink? 19. All right, excellent. Okay, cool. So the teens, looks like the teens. Interesting. I think I was 4. It's true. I was 4 years old. My dad used to, when we went grocery shopping, right? Back in the day, we used to go grocery shopping every Friday, and he bought his 6-pack of beer, right? And so I used to sit in the back, right? And he goes, "Mijo, can you give me a beer?" So back then you could drink and drive, so yeah. He just drank 1 beer. Anyways, he goes, "Can you open it too? And then you can take a sip if you want." So I took sips. And I was 4, and it continued on every Friday. And so there you go. There's my. So I was 4. And now I hate beer. I can't stand beer. But ever since my mom says it looks like meows, it even tastes like meows. I don't know beer for. All right, so this is what just based on the readings. Um, from our readings here, what age did you? Okay, teen years. The teen years were to occur. All right, so based on this, we're gonna just say oh, we didn't use the underline. Just use it right there. Percent. Okay, there you go. There's our confidence interval for this class. So between 0.924 and 0.985 are the number of people who drank beer during their teen years, right? So you can write it in this format. So this is how you read it. Okay, so this is how you read it. Well, it's 0.924. It's so P, remember, P is the population proportion. So the true population proportion occurs between these two numbers. If you want to write it in decimal, that's perfectly fine. If you want to write it as a percentage, it makes better sense if you write it as a percentage. They write it like this. They write it as 92.4% P, what is it, 98.5%. A lot of people like it that way instead of decimal, which is fine. That's perfectly fine. You can also write it, you don't have to write it as these compound inequalities. You can rewrite that as with parentheses. You can put 0.924 comma 0.985 close parenthesis, or you can write this as with parentheses, 92.4% comma 98.5%. So there's 4 ways that you can write your confidence interval. Any one of these is fine. You can write it as a compound inequality with decimal, with percent, or you can write it with parentheses as decimals or as percentages. It doesn't matter. You decide how you want to write it as. Either of these 4 are perfect. So we're gonna find these. Numbers, these inequalities, okay, and that's going to tell us more or less where the true population proportion is going to fall. It's somewhere in between these two numbers. I don't know what it is, but if I had to do it, I would have to calculate, which I already have all your numbers, right? I can actually calculate it and I'll find out that it is between these two numbers. I messed it up. So that's why it's like 98%. But yeah. 19, hold on. 1, 2, 3, 4. 4 out of 5. 4 out of 5. Okay, so I'm gonna and so that's what we're trying to find. We want to find an approximate result of where the true proportion is. So let's say that you want to do a survey in San Antonio and you find these two numbers. Well, you don't have to go and test everyone unless they question you on these numbers. So they do, that person has to go and collect all all 3 million people, they will find out that it is right in between these two numbers. I don't know what it is, but it's somewhere in between them. That's what estimating is doing. You're kind of more or less guessing where that number is. But these upper and lowers are going to be narrowing it down to a number somewhere in between. So how do I interpret it? Okay, so if you want to interpret it using words, symbols, terminology, how to write it. This is how you write it. Interpret. Okay, so you would write, we are blank percent confident that the true population parameter proportion of students who drank alcohol during their teen years is between 0.924 and 0.985. And so that's how you would interpret it, if you needed to interpret it.
I'm sorry, real quickly, can I see the paper before the one that you showed me?
Sure. This one. The one before the very, very beginning one?
Yeah.
Okay. Let me see if I can find it. I threw it somewhere. Or it flew somewhere. Hmm. Where did it go? Ah, I found it. This one. Is that the one, ma'am?
Yeah, there wasn't another one before that.
No, it was this one,
What was it?
that one, and then the voting one.
Oh, okay, never mind. Okay, thank you.
You know. Yeah. Ow, my ankle popped. My ankle popped. Okay. And so that's how you would interpret it. Right. So we're going to be getting, I'm going to show you guys how to get these intervals. These intervals are important. It'll give us an estimate of the true population. We don't have to interview all millions of people. You can get an estimate. You just get a sample. You just get a sample like our class. And then we can judge, hey, based on what we got in our class, I think that's overall San Antonio. It's going to be similar. I'm confident. Okay. Well, these uppers and lower numbers, this lower and upper, this is all dependent on this number right there. You see how I had a little blank there? This number is called your confidence level. Confidence level. This percentage here will either close the gap, get these two numbers closer to each other, or they may be a little bit more spread out away from each other. So that controls the adjustment on the intervals. It could be, the numbers could be more closer to each other, or these two numbers can be further apart. It could be, this could have been 89% and that 99 point something. Or it can also get them closer. It could be, this number could have been 93.7 and then this one 95.6. This controls the inward or outward of these two numbers. And there's three of them that we are going to talk about, which affects the upper and the lower. So what is a confidence level? Okay, so confidence level is, I lost the page. What do I have Drake written on my book? Drake. Not familiar with his music. All right, confidence level is the probability that the confidence interval actually does contain the population parameter. The confidence level will affect the lower and upper values of the confidence interval. And there's three of them that are used in real life. I usually do 6 of them, but I'm gonna pass on it. I'm just gonna show you the main 3. There's 3 of them. 3 of them that are most commonly used. There are 3 of them. There are 3 that are commonly used. We use the 90, 95, and the 99. Right. Those are the 3 that we use. You guys remember Goldilocks and the 3 Bears, right? When Goldilocks went and tried the porridge, right? One was too hot, one was too cold, and one was just right. Which of these 3 is the just right? 90, 95, or the 99? Which one is the right one? Any guesses? Not too hot, not too cold, just right. Any guesses? Which one is the just right from these 3? Correct. The 95 is just right. This one's too high. No, that's too low. This is too high. This one's just right. So that's what we go. That's what in the real world we use the 95. We don't use these because this one these two you can get into errors. It may not fall within that range. So yeah, the 95 is the perfect one. All right, so those are the three that we're going to be using. You're going to see these numbers. You all are going to see these numbers in the book. Okay, you'll see those often in the book. Okay, so let's see, confidence level. I got that. Confidence interval. Okay, let me go through what they call a critical value. What is a critical value? It's a value that's critical. What is a critical value? Don't worry, they're just terms right now, and I'm gonna condense it all into one, and it'll make sense. Just right now, I can smell your brains frying. I thought it was barbacoa, but it's your brains. All right. Critical value. Critical value. Oh shit, I forgot to put confidence level. Confidence level, you all will see in the book, they have it written as a CL. CL, that's how they abbreviate critical value. They write CL. Sorry, forgot to put that on there. CL is your critical level. Okay, critical value. What is a critical value? That would be CB. A critical value is the number on the borderline separating sample statistics that are significantly high, like me, or low from those that are not significant. Not significant. You'll see this this abbreviation, but this is the I guess you can call it a formula, but they have a Z and it's a subscript. It's got this little beep like that. It's subscript. Y'all know what that little beep is? That little thing right there? What is that called? Y'all know? Looks like a fish. Nice try. It looks like a fish. No, it's not a fish. No, it's not infinity either. It's close to it. No, it's not half an infinity. It is called, in Greek mythology, it is called alpha, not alpha, 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 alpha. And it's alpha divided by 2. That's the formula that we're going to be using to notate a critical value. Now, why do we need the critical value? What's the purpose of it? Well, let me tell you what it is, what you use it for. The critical value will help to compute the margin of error and help compute the margin of error, which will help to compute the confidence interval. Right? It's a formula embedded inside of another formula, which is inside of another formula. It's like trickles down. You need this in order to do the margin of error, which is also going to help us compute our confidence interval. It's like it's embedded in one. I'm not going to show you the margin area yet, but I'm gonna show you all the critical values. So if you all look on page 302 at the very bottom, they have the critical values for each of those confidence levels. So each confidence level has its own critical value. And so I'll show you what those are and how to compute them. So I'm going to scooch this down and I'm going to show you all how to find the critical values. I'm going to show you how they got that 1.645, 1.96, 2.575. I'm going to show you how to do those. How did they get those numbers on the bottom? Okay, so let me show you how to do it. I'm getting emotional. All right, confidence. Confidence is calendar. Confidence level. All right, so we have 90. We have 95. And we have 99. Okay. So yeah, I'm gonna need your help. How do you change 90%, 95, 99 to decimals? I want to convert these percentages to decimals. Anyone know? Right. Someone said it's 0.90, 0.95, and 0.99. Very good. That's how you change those. You just divide the 90 by 100, 95 by 100, 99. Those are written in decimal format. Now, next to those, I am going to put fish. What is fish? Not a creature that lives under the water. No, this is the alpha. What is alpha? Alpha is the complement to these numbers. Confidence level. All right, so think of it like this. You have 90 cents. What's left over to make $1? 10 cents, correct. Right? You have 95 cents. I want to make $1. How much am I missing? I'm missing 5 cents. Right. I have 99 cents. So how much do I need to make $1? I need a cent. Right. Does that make sense? These two, they have to add up to 100. That's what this fish is. They're the complements, the leftovers to make $1. That's what the fish is. And now I'm going to show you how to find the critical values. I'm going to show you how to do Z fish divided by 2. These are the critical values. Each one has its own critical value. All right, so I'm going to show you how to get those. They're each going to have z equals z alpha over 2, to be more precise. Right, so I'm going to show you how to get those. All right, so here's what you do. Let's start with the 91. Okay. So you're going to draw your picture. You're going to draw a picture of a bell-shaped curve. I'm going to do the first one with y'all. Okay. And you're gonna cut your normal curve into you're gonna cut it off at the left. You're gonna cut it off at the right, and you're gonna put the 0.90 right in the middle. Okay. And well, we know the middle part, the blue part right here, this part. This is 0.90. I want to know what these two ends at the end are. Well, I know both these sides, they have to add up to the leftovers, which is 0.10, right? Total. That's what the green part is supposed to be, total. If I add this green part with this other green part, that equals 0.10. So how do I find the amount per side, right? If these two add up to 0.10, I want to know what these two are each. Well, that's why you divide 0.10 by 2. This will give us this side. So if I divide 0.10 by 2, you get what? 0.05. 0.05. Can y'all double check? If you add those two together, do you not get 0.10? 0.05, 0.05. Yeah. Let me check it. Hold on. 0.05 plus 0.05. I'm supposed to get nothing. Yeah, I got 0.10, right? So that's where this fish divided by 2, you're dividing 0.10 by 2. That's your fish. And that'll give you the cap ends on both sides. So what we're trying to do, what we're trying to get at is I want to find my z value that cuts it off right there. As you remember from the previous section, I need to know the area shaded to the left. So it is shaded to the left. So I'm going to put that number in Statdisk so I can find my z. So I'm going to go to Statdisk. Let's see if I have it up. I forgot to load it up. Boschinitas. So I shouldn't say chinitas. Let me see. I don't think I have it open. Son of a biscuit. Hold on. Let me open it up. Okay, here we go. So I need to go back to my analysis, probability distribution, and I'm going to click on normal there. And I'm going to put the 0.05, that little number that I underlined, that's where it goes. It goes right here, 0.05. And right there, there's my answer. So my number is negative 1.64485. Right, because I entered the 0.5, that number that I put when I divided 0.10, right? I divided 0.10 by 2, I got 0.05. So that's where I put it in. I put it in right there, and that gave me that number, my z number right there, that one. And this is where the value is. That, right? So I want to know what this one is. Well, we know that it's symmetrical and both sides are both the same 0.05, this 0.05. So if this one on the left is negative, what should the other one be? That is correct. It's supposed to be positive. And so that's our critical value. It is positive 1.64485. You're thinking, why is it positive, sir? Well, the reason why we chose a positive is because you're figuring out the distance from this line to the center, which is 0. And when you measure things with a ruler or with a yardstick or whatever, right? Measurements are always measured in positive. So the measurement from there is positive, and the measurement from there is positive. It's just that this is negative just over here. And so that's our critical value for our 90%. And then you do the same thing with the other ones. We'll do the other ones too. Let's do the other one. Okay, so I'm gonna draw my picture. Jeez, I want the bigger graph. Anyways, so it's 95, which means that these lines are going to get closer in. This is 0.95. I'm going to shade it. I need the green, as my mom says, the green. So how do I figure out the green areas? Well, I know this is 95. I am left over with 0.05. So that's what both of these together add up to. But I want to find each of them individually. So you're going to divide 0.05 by 2, right? So divide 0.05 by 2. What is 0.05 divided by 2? 0.025. So that's what each of these sides are equal to, 0.025. And this one's 0.025. Y'all can double check. If you add them together, you're supposed to get 0.05. And that's what you're going to put in Statdisk. You're going to put this 0.025 first. And we're going to figure out that z-score value. So we go back to our Statdisk and plug in 0.025 into Statdisk. 0.025, right? And there is my z value. It's negative 1.95996. That's the left side, but I need the right side. If that one's negative, the other side must be, any guesses, any guesses, any guesses, any guesses? Positivo. And that's our critical value for the 95, 95996. That's how they got that number. Now I gotta do the last one. I gotta do the 99. Why are my graphs coming out huge? I'm gonna have to do it here, ladies. I'm sorry. I'm gonna have to squeeze it in because y'all can't see I'm going lower and lower. All right, so here we go. I'm gonna put my curve. Looks like a blemish I had when I ate at Fred's Fish. All right, since this is 99, actually it should have been outer. This should have been more out. My bad. I'm going backwards. Where's my whiteout? Desiree, what did you do with the whiteout? There it is. It's supposed to be further out. Because usually I do it the other way around. I do the smaller ones first. I mean the bigger ones first and then out. It should have been more out. Sorry. Yeah, it's getting this number inside keeps getting, it's growing further out. This is 90, and then 95 should go a little bit more outer, right? It has to go out. Terrible graph. Sorry, I don't know how to draw. $95. Yeah, close enough, right there, 95. Yep, good enough. So that means that 99 is going to be further out. Right. The bigger the number, the more area is covered inside the graph. You know what I mean? See how I drew it wrong? This should have been in, out, a little bit more out. This is further out. 99. Further out. Right? So if this is 99, the two greens on the end, they had to add up to 0.01. So I'm going to divide 0.0. You get this number divided by 2, and that'll give you the cap ends. Right? So put 0.01 divided by 2. You get 005. 005. This is 005. And you, just to make sure, add the two ends. You're supposed to get this green, 0.01. How do we get the 0.01? That was a complement of 99. You have 99 cents. You got 1 cent left. That's what you divide by 2. And this is the number that you enter in your Statdisk. 005. Need to stop smoking. 005. 005. Dun-dun-dun-dun. There it is. Negative 2.57583. There's my number. Therefore, I want the right side. The right side, we're going to get the positive. 2.5758. Oop, I ran out of space. Anyways, 2.57583. And that's how they got the numbers. You have to draw them each one individually so you can get the Z's for it. And if you look on page 302 at the very bottom, compare ours with the ones that the book has. What's the difference between our numbers and the ones in the book? Right? So if you look at the one in the book, let's look at the ones in the book. These are ours, right? And then look at the ones in the book on page 302. Look at the ones on page 302. 302. Right? They're the ones that I have in 3. Look at theirs. What the book did is they rounded their numbers, which they shouldn't have. Yeah, you don't want to round those margin of errors. Margin of errors are very, very important. So you don't want to round any value like that. Never. ever. Okay, so just letting you know, we're gonna use ours. We're not gonna use the books. Ours are gonna be more and more precise. All right, so now that we have our numbers, okay, we have our critical values. You're thinking, well, why do I need the critical values? All right, so here's the thing. When you read the book, and if you're gonna do it again, if you're gonna do the formulas the long way, all right, this is just the long way. If you want to use the calculator or Statdisk, is gonna make it so much easier for y'all. But if you want to do it the long way, you need to know your critical value. So if the problem in the book says your confidence level is 90, you know that your critical value that's going to be used on our case, because ours is more accurate, ours is going to be 1.64485. If the problem says 95% confidence, then you're going to use the confidence level interval of 1.95996. If the problem says 99%, you're going to use your critical value of 2.57583. So you got to look at these numbers and then use your notes that we just did right now. You're going to be referring to this table. Oh, I wrote over it. Son of a biscuit. You need these numbers. You need these numbers if you're going to do it by hand. Anyone going to do it by hand? Excellent. Everyone's going to do it by hand. Thank you. Excellent. Excellent. All right. Now I can show you all the formula. Again, if you're going to do it by hand, the margin of error, not margin of error, but margin of error. It's also abbreviated as MO. Yeah. Get it? MO from the Three Stooges? Sorry. All right, so here is the formula. They use E. E equals, I'm gonna put the formula up, and it's gonna be kind of breathtaking, I know. All right, so here's the formula. It's E equals Z alpha over 2, Z subscript alpha divided by 2, and then you have the square root business, and inside you have P hat times Q hat divided by N. There's the formula on how to calculate the margin of error. All right, any comments about the formula? Anything about this part inside the radical? Any comments about it? Is it me, or does it look like a clown inside the square root that's sad? Y'all see it? A sad clown? Or am I the only one that sees it? Y'all see it? You see the eyebrows and then the sad face? Is it just me? Okay, I guess it's just me. I guess it's just, never mind. But I just made an observation. Anyways. This is the margin of error. You're going to be computing this. Again, if you're going to do it by hand, you're going to do it by hand. Yeah, I see it. Good. It looks sad. I know. Maybe because it's Sharpies. I didn't put the Sharpies. Hold on. All right, ladies, you know what I'm talking about. We're going to go ahead and make these Sharpies a little bit more. There we go. Gotta get that Southsider. Gotta get that little, that mean look. There we go. Now it looks like a mean. Okay. So again, you're gonna do it by hand. We're gonna do one by hand, just to show y'all the gist of it. Okay. We're gonna compute this, and once you compute it, do not round the answer. Ever, ever, ever. Once you get your margin of error, then you can go ahead and compute your confidence level. Okay, how do you compute the confidence level? The confidence level formula is written like this. It's P hat minus E, parentheses, P hat plus E. You compute the left side of the formula, and then you compute the right side of the formula. And then these two, these you round to 3 places behind decimal. I'm gonna let you copy that. Copy the clown, copy the clown, copy the sad clown. We're gonna do one only. We're gonna do one problem only by hand. Is that all right? And then you'll see that doing one by hand, it takes out at least 10 minutes. At least 10 minutes. If you do with Statdisk, it'll take you 30 seconds. Quiet, quiet. All right, some of you are sending me hate chats. Why did you show us that at the very beginning? Calm down, calmate, calmate, calmate. Okay. You ready, ladies? Are you ready? I'm gonna share with you what the P hat is and the Q hat is in the end. I want to show you all what those numbers mean in the problem. Okay, so don't panic. I'll share with you what those numbers are. They're gonna be giving you. They're gonna give you the. They're gonna give you that number. Well, no, we already know what that number is. That's one of these. This number is one of these numbers. This Z alpha thing, it's going to be one of these numbers. You gotta read the book first, or read the problem, and they'll tell you. They're going to give you either it's going to say that, or that. Once you know what it is, then you just you put that number in the front of the square root, and they're going to give you the P hat. We'll have to find Q hat, and they'll give you the N. Right, so don't worry. I'm gonna share with you what all those are. So don't worry. All right, so let's go to page 312, and we're going to do a problem. All right, we're going to do on page 312. Let's see, 312. Page 312. Why is my thing not working? 312. All right, shall we do Mickey Mouse? Oh no, it's McDonald's. Sorry, we'll do some French restaurant. Have you ever heard of it? McDonald's. All right, let's do 13. All right. All right. So, all right. In exercises 13 through 16, use the given sample data and confidence level. In each case, you have to do A, find the best point estimate of the population proportion. B, identify the value of the margin of error. And then C says to construct the confidence interval. And then you don't have to do D. You don't have to write a statement. You just need to do all that. All right, so let's read it. In a study of accuracy of fast food drive-through orders, McDonald's had 33 orders that were not accurate among the 362 orders observed. Construct a 95% confidence interval for the proportion of orders that are not accurate. All right, so here's the first part. The first part says, part A, it says find the best point estimate. Okay, let's see. How many of y'all remember the best point estimate formula? Does anyone remember the best point formula? We had it at the very beginning. Best point formula. Anyone? What is the best point formula? Point estimate formula.
The parts over total thing, the P over X. And
You are correct, Madame. Hijo. Very good. That's right. That is exactly right. All right, so here you go. All right, so here's the formula. Okay, it's the parts over total. That's correct. So your p hat is equal to x over n. Very good. Okay, now let's go back to the problem and identify what is my x and what is my n. So x is the part and n is the total. Are they talking about the ones that were accurate or the not accurate? They want the not accurate. It says it there too, right? It says not accurate. They want the not accurate. So the not accurate is, there it is, 362. So I have 362 over, oh, no. I have it backwards, don't I? The 362 is the total, isn't it? Am I right? 362 is a total, and what's the part? How many of the 362 had inaccurate orders? Oh, 33. Hello. 33. Well, let me highlight it. I don't know why. So it's 33 over 362. Part total. Part total. There's my part. 33 total. And you're going to divide it out. 33 over 362. You're going to get the entire decimal. Don't round it. Please do not round. If you round, you're going to be in deep trouble. There you go. And leave it. Leave it all like that. Leave it as it is. Okay. That's your p hat. This is your p hat. Right? I already know what my n is. My n was the 362, right? That was my n. Is 362. My x is 33. Although my x is in jail. But my x is 33. I just need to know what q hat is. All right, so let me tell you what q hat is. Q hat is the complement to p. They are complements. So how do I find q? You're going to use this formula. 1 minus p hat. So you're going to do 1 minus this whole long ass number. 0.091160221. You're going to subtract it from 1 because they're complements. And we end up getting for our Q hat. Let me put in my calculator. I'm going to do 1 minus 0.091160. 221. All right, there it is. 0.908839779. And don't round it either. Leave it as it is. Okay. Again, we're doing this the long way, all right? I already told you it's going to take 10 minutes to do, right? I told you it's going to take 10 minutes. Right? Why do I have all these numbers? Well, I need all 4 of these numbers to compute my margin of error. Okay, so I'm going to compute my margin of error. Margin of error. So it's going to be E equals Z fish divided by 2 square root of P hat times Q hat divided by, and I don't know why my square root went way over there. Okay. I'm going to use that. I'm going to plug in these numbers. Now, the thing is, I need to plug in this number. I need to know in the book, what was my confidence level? Did it say it in the problem what my confidence level was? Let's go back. It should read it in problem 13. Who can find the confidence level? You're looking for 90, 99, or 95. Correct. Someone said 95. All right, go to your notes. What was the critical value for the 95? I lost the paper. Oh, there it is. I need the confidence level for 95. All right, the confidence level I see on the 95 was the 1 point something something. 1 point something something. What was it? 95. There's a 95. There it is. 1.959996. That's the 95. That's where that number goes. Okay. So that goes in front of the square root. Right? And then inside, I'm going to put my p hat. What was my p hat? That long, big ass number. 0.091160221. And I'm going to multiply it times my Q. My Q was also that long ass number, 9.908839779, close parenthesis, divided by N, 362. I'm plugging in the P hat. There's that number, that long ass number, goes there. I'm multiplying it times my Q hat, that one. And I'm going to divide it by 362. Some of you are already chatting. I don't like this. Too bad. You said you wanted to do it the long way. Ándale. Vámonos. All right, here I go. So how do I do it? All right, so what I'm going to do first is I'm going to calculate the inside part first of the square root. You got to do it in pieces, ladies. You got to do it in pieces. Otherwise, it's not going to come out. All right, so what I'm going to do is I'm going to multiply that number times that number first. Okay, I'm gonna multiply the top numbers first. All right, I'm gonna multiply those and I'll put the answer. I'm gonna put the answer above the 362. All right, so here we go. Make sure you turn on the calculator correctly. 0.09, make sure you type the numbers too correctly. 0.911602221 times 0.0.90883977.8. All right, this is what I get. Just double check, is that correct? Your calculator may be a little bit off, maybe like the last digit, maybe. It'll be a little bit off. Some of y'all may have another number after the 5. Some of y'all may have your calculator cut it off and make that a 3 instead of a 3, it's a 4. I don't know how your calculators are functioning, but that's fine. If it's off by the last digit is off by a little bit, you're good. You're good. All right, we're almost there. Almost there. All right, next I'm going to divide. I'm going to divide that long ass number by 362. You gotta do it in pieces. All right, I'm gonna divide that by 362. All right, here we go. Oh, shoot, I should never erased it. Son of a biscuit. Divided by 362. All right, I got a 0.000228868. I divided that by that. That's how I got. Okay. Almost there, almost there. Y'all are timing it, right? It is going to take 10 minutes to do one freaking problem. Right? And now I'm going to take the square root. I should have done that. My whiteout broke. Hold on, my whiteout broke. I don't like these whiteout pen things. These stupid pens. There. All right, I'm going to calculate. I'm going to do the square root of that number. I'm going to do second x squared 0.000228868. I have 3 zeros, 2288868. All right, hit square root, and you get this number, and that's what I'm going to multiply the red value to. I'm going to multiply that 1.95996 to this number 0.0151283884. Now I'm going to multiply that to that. Of course, some of you are saying, can I just type it all in one halazo and then get the answer? Yes, you can. All right, this is what I get. I get 0.0296511027. There is your margin of error. That's your margin of error. Dang, it's already 10. Oh. There's your margin of error. Some of you are not even writing it. That's messed up, man. That's messed up. You're gonna just show me the short way. That's fine. All right, so there's your margin of error. Okay, you don't round it. You leave it. Leave as is. All right, and now you're gonna calculate the confidence interval. Right, so here's the confidence interval. It's going to be, the formula is P hat minus E P hat plus E. You're going to plug in the P hat and the E, and you're going to subtract them on the left. That's going to be your lower. And then here's your upper. You're going to do P hat plus E. Why did I make that high pitched sound when I said plus? Anyways, we're going to go back and get our P hat. What was our P hat originally? Our P hat was that long ass number. I'm going to write it down. Our P hat was 0.091160221, and I'm going to subtract my E. This is my E. I gotta do it in a green color. This is my E. 0.029651027. I'm gonna run out of space. And then I'm gonna do that number again. I'm gonna run out of space. 0.911602221 plus the green 0.029651027. And we're gonna calculate this, and you're gonna calculate this. I'm gonna put the numbers next to them. All right, so let's do this one first. Is your hand hurting? Excellent. I told you that you shouldn't do it the long way. Anyways, 0.091160221 minus 0.029651027. Okay. So this is what I get for this side. I got 0.0615099194. Yeah. And then the other one, I'm going to type that plus that. Cheat. 0.12081124.8. I cheated, ladies. What I did, I'm gonna show you what I did. On my TI-30, if I hit the little arrow, it gives me the previous formula. I hit enter, I look for it, I find enter, and then I just go back and change that minus to a plus. That's all I did. But y'all knew that. Right. And so on these, you have to round to 3 places. So I have to have 3 digits behind. So this is 0.062, and this is going to be 121. 121, or if you want to write it as a percentage, 6.2% and 12.1%. So that's the for McDonald's, that's the percentage of inaccurate orders which occurred. It occurred to me, where did we go? Well, it wasn't McDonald's. Yeah, McDonald's is pretty accurate with my orders. The one that's not do a good job is the Whataburger. They're so good, but they always forget stuff. Like I asked for tea half sweet, half unsweet, and guess what they gave me? They gave me this freaking sweet. Like, or they forget to put the spicy ketchup or something. McDonald's is pretty good. All right, so that's the long way of doing it. The long way of doing it. All right, so are you ready for the shortcut? Yay or nay? Y'all like the long way? Shall we just keep it like that and not even show you the shortcut? You're good? All right, let's move on then to the next section. All right. I'll show you the shortcut. No, no. So, the shortcut. All right, so I'm gonna go back to the problem. You guys do have to do this formula by hand. You have to do the best point estimate. You have to do that by hand. The other stuff you do not. Okay, so how do I do the shortcut? So if I want to do part B, if I want to do part B and part C, the shortcut, all right? This is what you do. All right, so for part B, I want to use Statdisk. Okay. You need 3 numbers, okay? Find 3 values. You're going to find your confidence level. You're going to find your X, I think it's X. Yeah, X, and then your N. All right, that's all you need. Okay, so I know from my problem that my confidence level was, I think it was 95, but you have to change it to a decimal. So 0.95 is my confidence level. My X was 33, and my N was 36. I may have these backwards. I'm not too sure. Anyways, let's see. Let's find it. All right, so we're gonna go to Statdisk. All right, I'm gonna show you where to go. So in Statdisk, you're gonna go to. Okay, let me go back to it. Right, you're gonna go to Analysis, right here. You can see it. You go to Analysis. You click on Confidence Interval. All right, confidence interval. And you're going to do proportion 1 sample. This proportion 1 sample, you're going to just do that for section 7.1. 7.2 is mean 1 sample. You're only doing 1 samples. This is 7.1. This is 7.2. All right. 7.1, 7.2, 7.1, 7.2. All right. So we're going to click on proportion 1 sample. Ah, see, I have it backwards. Son of a biscuit. You put your N first, and then you put the X. Chihuahuas. So N goes first. 362, and then you put your X of 33. Right? All right, so I already put 95. I'm gonna put 362, and I'm going to put 33. You ready, ladies? Are you ready? Are you ready? You hit evaluate. Boom! There's your margin of error right there. There's your margin of error. And the middle part, this part, there is your confidence interval that we just did by hand, which took us 10 minutes to do. It took us 33 seconds to do. Are you impressed? The only thing is that on your margin of error, Statdisk rounds it off, which is fine. You're just going to write that number down. That's it. Here is your confidence interval. We have computed it. We need to round these numbers to 3 places behind. So you're going to have to do that by hand. Don't do the third one. The third one is Wilson score. We don't do the Wilson score. The only time we saw Wilson was from Castaway. Remember the little volleyball? Mr. Wilson, Mr. Wilson. We don't do that one. We only deal with this and that. Bam, that's it. So all the problems that you're going to do for the homework, you're going to find these 3 numbers, plug them in. write down your margin of error, write down your confidence interval, round it to 3 places. That's all you have to do. Huh? Easy? Easy. All right, so shall we do a couple more so I can get the feel for it? What do you think? Excellent. Let's do 15. We'll do 15, the shortcut. Is that all right? We shall do 15, the shortcut. All right, 15 it is. Let's do 15. All right, so 15. In a study of cell phone use and brain hemispheric dominance, an internet survey was emailed to 5,000 subjects, randomly selected from an online group involved with ears. What? 717 surveys were returned. Construct a 90% confidence interval for the proportion of return surveys. All right, so we got to do A first. We got to find the best point estimate. All right, so we got to do that one by hand. Sorry, we got to do that one. Best point estimate. All right, so we're going to put P hat equals X over N. What is your X for number 15? Correct. 717. And then you're going to divide it by 5,000. So 715 divided by 5,000. Sorry. Equals, I need to take my calculator. 717. Hello. Make sure you turn on the calculator. ¿Qué cosas? 0.1434. Done. Part B. All right. We're going to do part B and part C. We're going to let Statdisk do it. All right. So let me see if you guys remember. There were 3 numbers that you had to identify in the problem. What were they? You needed your confidence level. I need my N, and I need my X. I don't need my X. She's good and Joe. I know my X was 717. My N is 5,000. What is your confidence level for this problem? Confidence is Cavender. Where is it? Oh, it's 90. I need to change 90 to a decimal. How do you change a 90 to a decimal? Is it 0.09 or is it 0.9? Correct. 0.9. That's too sharp. 0.9 or 0.90, whatever. Okay, so I'm going to enter these 3 numbers, ladies. I'm going to enter these 3 numbers in Statdisk. I'm going to enter that number, and that number. And it's going to give me my margin of error. That's what I need. I need my margin of error. I need my E. And then part C, I need my confidence interval. Okay, here we go. Here I go. Plug it in. They're all going to be like that, ladies. All of them. All of them. Point 90. 5,000. 717. Oh, no. Gotta be. All right, there's your margin of error. Write it down. I'm going to write it down as it appears. 0.00815. And then your confidence interval, there's your margin of error. I'm gonna write it down. And then your confidence interval. Yeah, I wanna write it with just 3 digits behind the decimal. 0.135 less than P less than 0.152. Done. Done. Done over done. Sopas. All the problems are going to be like that, people. All of them. All of them are going to be that simple. Questions? Concerns? Shall we do another one? You guys can pick. You guys can pick problems for me. You have from 13 through 27, I think. Can you show me the bottom part from the previous one? Oh, from the previous one. Oh, the long way, ma'am? The long way. That one. Yeah, that was a long way. The long way. Yeah. I didn't say that's about a long way. That makes sense? Do y'all like Statdisk now? Do y'all like it? I didn't say love. That's kind of a hard word right there, but y'all like it? Isn't that quick and swift? Chum and sopas. And sopas. All of them, ladies, are gonna be like that. I think pretty much you're just gonna do part B. And I think they only ask for a confidence interval, I think. I'm not too sure. Anyways, I'll let you ladies pick. What? Uh-oh, I missed your chat. Yes, but part B on Statdisk. Oh, part B on Statdisk? Part B on, oh, you only like part D from, that's the only part you like, really? I thought you were gonna be impressed. Okay, I'm gonna let you ladies pick. I want you to pick the most difficult problem in the exercises. You're going to pick 17. Are you interested in births? Fast food accuracy. Ooh, oxycodone. That's some good stuff. Oxycodone. Touch therapy. Cell phones and cancer. What's the other one? Or smoking stopped. Which one would you like, ladies? You pick one. I think the only Hispanic mention in this book is number 21. Anyways. You want to pick one? Pick one. 17, 19, 21, 23, 25, 27, or 20. We can do 20. Oxycodone. Y'all know what oxycodone is? That's some good stuff. Oxycodone. You want to pick one? $21. Excellent choice. You almost picked oxycodone. All right. All you ladies that are going to be nurses, hey, hook me up in case I need it. All right, that's addictive. No. All right, let's do 21. Touch therapy. This is a very touchy subject. Get it? Very touchy subject. Anyways. 21. So when she was 9 years of age, Emily Rosa, sorry, I didn't roll my R's. Emily Rosa did a science fair experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or her left hand, and then she asked the therapist to identify the selected hand by placing their hand just underneath Emily's hand without seeing it and without touching it. That's pretty creepy. Among 280 trials, the touch therapists were correct 123 times. All right, so there's part A. It says, given that Emily used a coin toss to select either her right hand or her left hand, what's the what proportion of correct responses would be expected if the touch therapist made random guesses? So it's mimicking a coin toss. What's the probability of flipping a coin and getting a heads or tails, ladies? That's what it's mimicking. What is the probability of getting a, it's like a coin toss. It would be what? That's correct. 50%. Excellent. Yeah, there you go. There's part A. There's part A. All right, part B. Part B says, using Emily's sample results, what's the best point estimate of the therapist's success rate? All right, there's the key word, best point estimate. We need to compute the best point estimate. So it is P hat equals X over N. What's your X? How many were successful? Oh, 123. 123 over 280. Is that correct? Among 280, they were correct 123 times. All right, so let's calculate it. What is 123 over 280? Well, you ladies are going to want a whole bunch of these problems on your test. Oops, wrong one. Hold on. Easy, ladies. Easy. We used to do this by hand. We used to use, back in the day when dinosaurs roamed, we used the sun. All right, here we go. 0.0.439285714. Now, remember, this is supposed to mimic a coin flip. This is the success rate of her identifying the hand. Is she doing a good job compared to 50%? It don't look like it. It looks like it's going lower. I think flipping a coin has a better chance than her. Anyways, we'll see. Anyways, we'll see. All right, and I think that's it. There's your best point answer. That's your P hat. That's part B. And then part C, what did they ask in part C? I don't know. What did they ask? What did they ask? Using Emily's sample results, construct a 99% confidence interval estimate of the proportion of correct responses made by the touch therapist. Okay, what is your confidence level, people? There it is, 99. I gotta change that to a decimal. So I gotta change that to 0.99 is my confidence level. My CL is 0.99. My N is 280. And my X is 123. I'm going to put those numbers into Statdisk, yeah. And I'm going to get my confidence interval. 0.99, 280, and 123. They only want the confidence interval, so that's all they want. They want the confidence interval. There it is. So round it to 3 places. So I'm gonna write it different. Okay, I'm gonna write my confidence interval different. Instead of writing those inequality symbols, I'm gonna write it different. I'm gonna write it with parentheses. 0.363, comma 0.516. This is how I wrote it. You can write it like this too, ladies. You can write your answer in parenthesis format, in interval format. You can write it like that. Or you can write it as 36.3%, comma 51.6%. So her success rate is between those numbers. I don't think she's doing a good job. I'm gonna conclude, get a real job. Get model, right? That's it. He's only 9 years old. What is he done? All right. What is he done? She meant well. Hey, she did the experiment, you know? Hello. Hello. So yeah, her success rate isn't that good. It's, I don't know, I guess more than 50, I don't know. Something. But yeah, that's how you can write it. You can write it like that if you want. So conclusion, Emily's success rate is similar to flipping a coin. Now, if these had been like 98 or 86 or something, dang, she's good at it. But yeah, it's too low. I wouldn't be comfortable with that. She's not doing that. Not that there's anything wrong with that. Yeah. Questions, ladies? You like these? These are fun, right? Remember, what you need 3 numbers. You need 3 numbers if you're going to use Statdisk. You want to do the confidence interval for proportions. This is for proportion. Right? It's got to say proportion on there in order for you to extract these numbers and then use Statdisk. Oh, I didn't show you how to do it with a graphing calculator. Does anyone have a graphing calculator? Y'all have one of these? Anyone? Anyone have one of these puppies? I can show you. Does anyone have one? I can steal one from y'all, from my neighbors. I can just go over the house and steal. Anyone have one of these puppies? All right, you want me to show you how to use it? Okay, so the directions, you can get these numbers on the calculator. You let me show you on the handout. I just don't know where. Oh, okay. Oh, you don't know where it's at. Okay, never mind. Never mind. You don't have a app on your phone that can detect where you left things, no? Doesn't your calculator have detection settings where you lose it, you can press a button and it'll beep it or something? Well, never mind then. Never mind, we'll just use that. All right, all of the problems that you're going to encounter, you're going to probably do that and then do this. That's all there is. There's nothing difficult. I don't expect you all to do it the long way. All right, I suggest you don't even touch the long way. But if you want to do it, go ahead. It doesn't matter. It doesn't matter. You want to do the quick, easy way, Statdisk is the best. So remember, you need 3 numbers. It has it on the handout too. I think on page 2 of your handout, it has what you need to enter. But other than that, it's simple, 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 simple. Right? Just remember, you gotta look for the word proportion, and then that's what you have to identify, and then find your stuff. All right, so the rest, I think there's like 5 problems you have to do. Piece of cake. The other ones, if we go beyond, let me see. Let me show y'all my little handout. You guys are in the way. Get out of the way. All right. So there's the second page. That's how it shows you how to find the margin of error and confidence interval. Right. There's directions, page 2, blah, 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 blah. Don't print it. Right? You don't know where it's going to print to. So I wouldn't print it. Right. So there's that. All right. So now on the second part of this section, they're going to ask you to find the sample size. All right. So if they ask you to determine the sample size, this is where if you're asked to do a study and they ask you what should your sample size be, this will tell you an estimate of what sample size you should conduct for your field of study or whatever study you have to do. You can ask it to give you a number of how many people you should survey for your experiment to be valid. Right? So you're going to go to analysis. You're going to click on sample size determination, and you're going to click on estimate proportion. Okay. Once you hit that, you're going to enter these 3 numbers. The confidence level, your margin of error, and you're going to enter your estimate of P. Now, sometimes this third box may not be given. If it is not given, you're going to leave it blank. That number. They may or may not give it to you. So if they don't give it to you or it says unknown, if it's unknown, you're going to leave it blank. But if they give you a third number, you go ahead and plug it in. And don't put anything in that 4th box. That's just niet. Don't put it on there. You type it all in, boom, you'll get your sample size right here. This number right there, you're gonna get. Not that exact number, but you're gonna get the number. All right, so let's do a couple of them so you can understand. So these are the 3 things you need. I'm gonna write it down. What do I need for sample size? Sample size. I need confidence level. I need margin of error. And I need, well, I don't need it, but it may or may not be given the 3rd option. What is it called? Estimate of P. Estimate of P. I'm going to put a question mark because sometimes it's a mystery whether it's there or not. Okay, so let's do one. I'm going to write it down. I'm going to share it with you, what you need to find. Let me share it on the screen. Alamo. What the frog happened? What did I press? Weird. 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 All right, this is what you need. Sample size. CL, margin of error. Put a question mark. May or may not be given. Estimate of P. All right, now the problems you're going to look at, I think it's problems 29 and above. I think. I'm looking at my book. Hold on, let me look at my book. Let's look at the book. See if I can find it. Okay. Yeah, it was 29. 29. Oh, wrong one. 29. Oops, I went too far. Son of a biscuit. Astrology. Astrology, what the heck? Is that the one where they look at the Sagittarius? I don't know what that is. All right, cool. No, it wasn't 29. It was 31. 31. 31. Knew it. 31. All right. Do we have any lefties in the class? Any of you ladies are left-handed? No one's left-handed? What? No one is left-handed? That is weird. None of you ladies are left-handed? I thought y'all were left-handed. It's one of y'all had to be left-handed. That's interesting. Y'all are all righties. Discriminators. Interesting. All right. Anyways, you're not left. Anyways, let's do it. Find the sample size. See, it says right there. Find the sample size. Sample size needed to estimate the percentage of California residents who are left-handed. Use a margin of error of 3 percentage points and use a confidence level of 99%. All right, right there, they gave you two numbers. They gave us the, what was it? They gave us the confidence level, right? Confidence level is 0.99, is that right? And they gave us the margin of error. Okay, now the margin of error, I think you're gonna have to change that to a decimal. So 3 percentage points, I gotta change 3% to a decimal. So I'm gonna divide 3 by 100. And so that should give me 0.03. Put it in your calculator. And notice on part A, what does it say? It says assume that P hat or Q hat are unknown. All right, so we're gonna leave the third box empty. I'm going to leave it empty. Leave the third box empty because P hat unknown. All right. Known. Is that right? Is that the right word? Canon? Canon. Canon. Right. So 0.99. Right. 3 divided by 100. 103. And we're going to leave the third box alone. Alone. All right, margin. Okay, so here we go. Let's plug it in. Plug it into Statdisk. All right, where do I go in Statdisk? All right, so you're gonna go to okay, I'm gonna go back. Oh, you're gonna go to analysis right there. Analysis, sample size determination right there. And we're going to do this one is 7.1. This one is 7.2. 7.1, 7.2, 7.1, 7.2. We don't do that. We don't do the last one anymore. They took it off. So that's 7.1, 7.2. We're gonna do 7.1. And we're gonna plug in the numbers. 0.99, 0.03. I'm gonna leave that alone. I'm gonna leave the other one alone. Evaluate. There's your sample size. Sample size is 1844. That was a good year. 1844. Of course, there were people shooting at each other, Indians getting their land taken away. Yeah, that was bad. Never mind, it was a bad year. Sample size is 1844. 44. The end. That's it. That's for part A. All right. Now, part B, I think you have to use the same thing, but the only thing extra that I think they're going to give you an extra number, which you put in the third box. I'm just going to double check. Yep. B says assume that based on prior studies, about 10% of Californians are left-handed. All right, so we're going to use the same. We're going to use the same CL, 0.99. We're going to use the same margin of error of 3% for 3 over 100, which is 0.03. And now they're giving us our p hat, which is 0.10. 10% is 10 over 100, which is 0.10. And so now we're going to enter those three numbers. Let me share with you what I got. .99, 0.03, and now they're giving us that extra number. I'm going to enter all three numbers now. The previous one, we only entered two numbers because the other one was unknown, right? But now we have three. I'm going to enter that and get my sample size. All right, let me enter it in Statdisk. Did I say it right? Statdisk. Oh, wrong one. Oof. Sample size is 660. Woof, we were off by two numbers. Thank goodness. Hijo. I have to light some candles. Right? That number had fallen on that other ugly number. No bueno. There you go. Freaking Ford doesn't want to come out. I got to tell y'all really don't like rounding. Y'all suck at rounding. My goodness. You have to work on your rounding. Work on your rounding, people. PU, y'all stuck at rounding. As y'all notice on your test. Whap, whap. I have to send y'all your test back. So today I'll send it back. But 664. If it's not given, you leave it blank. If it's given, you plug it in. 1, 2, 3. 2 unknown, 3 known. Questions on the sample size? You want to do another one? You can do another one. I don't mind. You can do the next one if you want. I'm gonna let you copy it first. I'm going too fast. I'm going echa la madre, right? Going fast. Okay. Ready? Ready? Steady? Steady? Let's do another one. Let's do. Oh, how many of y'all have had chicken pox? Have any of y'all ever had chicken pox? None of y'all have had chicken pox? That means you guys already got the shot. Didn't y'all get the shot for chicken pox? I had it. Now you know what that means, right? So when I get older, if you had chicken pox, you're likely, highly likely to get shingles. Have you heard of shingles before? Yep. My mom and dad had the shingles. That's like grown up. That's like older folk shingles, but that one's painful because it forms along your spine of your back. So yeah, it's bad. So no, you guys are young. You got inoculated with the chicken pox. How rude. I feel old now. Sad. Chicken pox. That was vicious. All right. I didn't want to do chicken pox. Just asking. All right, let's do bachelor's degrees. Bachelor's degrees in 4 years. In a study of government financial aid for college students, it becomes necessary to estimate the percentage of full-time college students who earn a bachelor's degree in 4 years or less. Find the sample size needed to estimate the percentage. Use a 0.05 margin of error and use a confidence level of 0.95. What the frog? They changed it for us. How rude. All right, let's see. What do they ask? Assume that nothing is known about the percentage to be estimated. And then B says, assume that the prior studies have shown that 40% of full-time students earn bachelor's degrees in 4 years or less. All right, cool. All right, so one, you do put in the third value, and the other one, the first one you don't put the value, and the second one you do put in the value for the third box, right? Right. So what is your confidence level for number 33? So my confidence level is 0.95. They gave you margin of error. Margin of error. Oh, they changed it to a decimal. How nice. What do they have? 0.05. All right, here we go. Let's get the sample size. I'm only going to enter the first two because it said that the p hat was unknown. Unknown. Why do I have mocos? I'm having issues with my brain. Because I didn't eat cereal today, ladies. I didn't eat my tostos. Sample size. All right, here we go. I'm going to plug in 0.95 and 0.05 on Statdisk. Wait a minute. Let me show you what I have on my screen. 0.95, 0.05. Enter. Why do I keep pressing that? 95. And I'm going to leave that one blank. All right, here we go. Answer is 385. The end. Well done. I think B do the same thing, but same numbers for your CL and your margin of error. But your P hat is Canon. What was the P hat for part B? I think it was 40. Not too sure. Was it 40? 0.40, 40%, 40%, you divide 40 by 100, 0.40. Punch it into your Statdisk. 0.40. Get out of the way. Get out of the way. Answer is 369. I think part C asks, is there a big difference between 385 and 369? No. No. I don't think so. Okay, cool. So questions? Any questions? No, you guys are awfully quiet. You've always been quiet. Okay, let me share it. Let me share my screen. We should have a party at Natalie's house, the same. Or Victoria's house. It is Monday. Why my house? Because yours is, I don't know, you have, yeah, you cook well, don't you? Don't you all cook good? No. Because you got voluntold. All right, cool. We can have it in Enriqueta's. She doesn't mind. I'll bring the napkins and the salt. And the sporks. Excellent. No parties allowed here. Okay, all right. Yeah, I agree. Yeah, we're not allowed to have parties Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. Or Sunday. Only on leap year. That's the only time. All right, no problems. I would have brought cereal. All right, very good. Excellent. Questions? All right, so let's summarize it. All right, we're going to summarize. We're going to summarize this, ladies. We're going to summarize it. All right, this is section 7.1. It's called, remember, it's called estimating a population proportion. All right, that's the key word, proportion. All right, so if you're asked to find the margin of error or the confidence interval, and you're going to use Statdisk, right? You're going to find the CL, the N, and the X, right? Your margin of error. Do not round. Confidence interval. Round to 3 places behind. Right? That's part 1. Okay. And then the other part was part 2, right? Part 2 was the sample size. Find sample size. Right? You're going to find the CL, the margin of error, and then p hat. Well, I'm going to put a question mark because it may or may not be given, right? I put a mystery, a little question mark. Right? And that's it. And then you get your sample size. Done, done. That's it. There's your shortcuts to doing all the problems in 7.1. It should take you to do all the problems. It should take you like 15 minutes to do all the homework on that section. What was the last exercise number? Oh, it was 33. 33. 33. Yeah, 33. No, this is all 7.1. We haven't done 7.2 yet. Now 7.2 is a different. 7.2 is a different. Yeah, I'll show you how to do 7.2. No, 7.2 is a whole different breed. Right? But this is all 7.1. All 7.1. I get it's all messy. I know it's all messy. Look at the handout that I gave you all. That handout that I just sent you out through the chat. It's all organized. It has all of this, all of that. I think this is page 2, and this is page 3 of the handout that I gave you all. It's all nicely neat. This is all, you can tell Amel wrote this, right? Yeah. But the handout is provided. Okay. All right, we got time, right? Now we're gonna go through 7.2. It's gonna be even easier. So I'm not gonna show you all the long way how to do 7.2. Is that all right? I'm gonna show you all the shortcut. Would y'all like that instead? If you understand how to do this, how to have access to Statdisk, it's gonna be extremely similar on 7.2. Very similar. Okay. So don't worry, be happy. Is there a song that says that? Don't worry, be happy. Can't see that. Can anyone sing it? I'll give you extra points. Maybe not. I was hoping I'd get takers. Yeah, I'll add, if you sing it, I'll give you 10 points on your 7th exam. No takers. Qué lástima. Ni modo. Ni modo. All right, let's do it. All right, so on 7-2, okay? I'm gonna give you the title of it first, okay? It's called Estimating a Population Mean. Okay, population mean. I'm gonna underline it. Okay, and we're gonna find 2 things. Again, we're gonna find the margin of error. So part 1, finding the margin of error or the confidence interval. Let's find the paper. This section should take us like 10 minutes or 15 minutes. One of the two. Simple. Very simple. Okay, so you want to use Statdisk, right? Okay, so on Statdisk, enter, we need the CL. Okay, let me show you. I'm gonna open up Statdisk so y'all can see where to go. All right, so on the handout that I gave you all, if you go to it, the handout, you're gonna go to section 7.2. You're gonna go to the 2nd page. All right, go to the 2nd page of that handout, not the 2nd page. You're gonna go to the, I think it's page 6. There's 5. All right, there's page 5. And you just want to go to page 6. And it tells you what to do. You're going to use Statdisk. You're going to go to analysis, confidence intervals. You're going to click on mean 1 sample, right? Mean 1 sample. And you're going to open up this window. So instead of entering 3 numbers, you're going to enter 4. Now, when you enter those 4, you see this 10? All right, this 10 number, just remember, if they give you the S, right, S, the sample standard deviation, you're going to put the number in this box right here, all right? So either you put the number on the 4th or the 5th, okay? If S is given, you're going to put it there. If the O is given, you put it there. There's the S and there's the O. Now, in your exercises, you are going to put the number in the 4th box. The only time that you're going to put the number in the 5th box, the only time, is if you see that curly O symbol, the population standard deviation. I didn't draw it nice. The curly O. It's got to be, the symbol has to be present in the problem. If you don't see that symbol, it's always going to be an S. Always. All right. I just put the number there because the symbol has to be present in order for you to put that number in the box. And you leave this blank. And same thing, if you know S, you put the number there and you leave that blank. Right? So just to let you know, all the problems in this section, you're going to put it on the 4th box. Now, on the exam, I may trick you and put the O on there. If I put the O on there, remember, you're going to put it in that 5th box. Hint, hint, hint. Just letting you know. All right, so let's do one. So what do we need? We need to enter my CL. I need my sample size. I need my sample mean. And either I know my S, my S. Is my S big? What do you think? All right, S and then O. Well, one of the two. We need to decide which is which. All right, so there's what we're looking for, ladies. We're looking for these numbers in the book. In the book. I gotta find for sure the CL, the sample size, the sample mean, and then one of the other. I need to enter it. All right, so here we go. Let's do one, shall we? Let's do number. I don't know what you're interested in. Are y'all interested in? No alcohol, right? And then Natalie said no parties at her house, so there goes that. That goes with Enriqueta. We didn't ask Desiree if we can have a party. All right, we're gonna go to page 228 in your Libro, and let's see. I don't know which one to pick. I don't know which one to pick. A homework party. There we go. Now we're cooking. Now what would you bring for your side dish? I would bring Brussels sprouts and asparagus. What do y'all think? And kale. And spinach. I guess not. All right, y'all want to do? You want to do birth weights of girls? You want to do mean body temperatures, or do you want to do Atkins? Is Atkins weight loss one an option? No. Insomnia treatment, garlic for reducing cholesterol, genes, speed dating, mercury and sushi. That sounds appealing. Celebrity net worths. Is my name on there? Nope. Or that's it. Which one would you like? Celebrity net worth. All right. Someone said mercury and sushi. That sounds delicious. Mercury and sushi. All right. Where is a good place to eat sushi at, ladies? Good place to eat sushi. Someone said HEB. Nah. All right, we'll do sushi and all right. An FDA guideline, an FDA guideline is that the mercury in fish should be below 1 part per million. Listed below are the amounts of mercury found in tuna sushi sampled at different stores in New York City. The study was sponsored by the New York Times, and the stores in order are Di Agostino, Eli's Manhattan, Fairway, Food Emporium, Gourmet Garage, Grace's Marketplace, Whole Foods, HEB, La Michoacana, La Fiesta, and Culebra's Meat Market. Bam! We got them all. All right, construct a 98% confidence interval estimate of the mean amount of mercury in the population. All right, so what do we know from our sample here? What do we know? Do we know our confidence level? What is our confidence level, ladies, for number 19? What is our confidence level? Oh, they want us to do what? What do they want us to do? Do they want us a confidence? What do they want? They want us to do a confidence. Oh, they want a confidence interval. Hello. Okay, so we need to do a confidence interval. All right, so we need to write down my CL. I think my CL is, what is that? 98. 0.98 is my CL, right? What is your sample size? How many samples did they do? How would you know that? Yes, someone counted these. That's correct. 1, 2, 3, 4, 5, 6, 7. Yeah, there are 7. My sample size is 7 because there are 7 readings. All right. Do I know anything about my sample mean? And do I know anything about my S or my O? Nope. All right, so we're not given the sample mean or the standard deviation. So what do? Well, I know I got my data there. What I'm gonna have to do is I'm gonna have Statdisk figure out the mean and standard deviation for us because we're not given that. So what I'm gonna do is I'm gonna type those 7 numbers in into my Statdisk. So you're gonna go to Statdisk and you're gonna enter that on the spreadsheet right there. You're gonna put the numbers in. You put your data in there, 0.56, 0.75, 0.10, 0.95, 0.95, 1.25, and 0.54, and 0.88. Right? You put your numbers in, and you're going to click on Data Tools, and you're going to click on Explore Data. Right? You type the numbers in, you click on Data Tools, and you hit Explore Data, and it should calculate. Select column 1, and presto, there's your mean, Jelly Bean. Oh, there's 7. Look, there's your sample size. N is 7. There's your mean. You're not going to round it. Leave it as it is. So my mean, Jelly Bean, is 0.71857. And I got to find my standard deviation. Well, because this is a sample, there's the S. My S is small. Been working out. 0.36576. So we don't know the O. My S is given. So there's your sample size, and there's your mean, and then there's your S, your sample standard deviation. So there it is. We had to have Statdisk compute them for me. So now I can go to Statdisk and go to confidence intervals, and I'm going to click on mean 1 sample. And I'm going to enter the numbers. 0.98, 7, 0.71857, and I'm going to put my S. You put the number in your S. 3, that didn't sound nice. 6, 5, 7, 6. And we don't know the population standard because we don't know what it is. We leave it blank. That was given to me. Statdisk gave us those 3 values. And then you hit evaluate, which I'll do in a minute. In a minuto. right, here we go. Presto. Round these numbers to 3 places behind the decimal, people. And you just leave it like that. You don't have to convert them to percentages. That's it. That's the answer right there. You just round it to 3 places. So my answer is 0.284 less than mean less than 1.153. Presto. Switch. And bam. Mercury and sushi. Look at that. That's exactly what the back of the book has. Booyah. The end. I'm telling you, that's how the book, all of the problems are gonna you're gonna enter those 3. Even the S, they're all gonna be with S. All of them are going to be S. But on the test, I may give you one just to throw you off with the O, letting you know. All right, so there's 19. That's it. That's all you have to do. You want to pick another one? Pick another one. We did the sushi and Mercury. We have mean body temperatures, insomnia. Ooh, garlic for reducing cholesterol. Is that true? Does garlic reduce cholesterol? I think it lowers high blood pressure, but I don't think it reduces cholesterol. I had a teacher in high school that, he had a cholesterol issue. And he was popping those garlic pills. Holy smoke. Man, you did not want to ask him a question. My word, you could see like a mirage, like from the back. You know how it's hot outside, you see a mirage? Man, that dude popped, I don't know how many pills of garlic. Damn. Even the bugs wouldn't fly near it. They would just die on the spot in the air. Just die on the spot. Pobrecito. He passed away, but well, I don't think it was for cholesterol. Other issues. Really cool teacher. Anyway, pick one. Pick another one, ladies. Pick another one. What would you like? Celebrity net worth. Speed dating, genes, garlic, insomnia, Atkins, weight loss. What the heck is an Atkins weight loss? The one where you just eat meat. I don't think I can do that. I do the Pilates diet. Is that correct? Am I saying it right? Pilates, is that correct? Am I pronouncing it right? The Pilates diet? Pilates. Any other ones? Pick one. Pick one, ladies. Pick another one. Whatever. I'm ready. You want me to just pick one, just at random? Yes? No, yes, no, yes. No, yes. All right, I'll do let's do the insomnia. How many of y'all have insomnia issues where you can't sleep? If you do, let me know. I'll give you some papers to grade. That'll put you to sleep. All right, let's do 13. Since it's in your homework, right? Am I right? Am I right, ladies? Am I right? All right, here we go. Let's do 13. Insomnia. I don't think I've ever had that issue. Insomnia. Okay, let's read it. Let's read it together. So, insomnia. Believe me, when you have kids, you will not develop insomnia. All right, here we go. Number 13. A clinical trial was conducted to test the effectiveness of this drug. I can't pronounce it. Zipoclone. Did I pronounce it right? Zipoclone for treating insomnia in older subjects. Before the treatment with Zipoclone, 16 subjects had a mean wait time of 102.8 minutes. And then after the treatment with Zipoclone, the 16 subjects had a mean wait time of 98.9 minutes. Minutes, I was going to say minutes. And a standard deviation of 42.3 minutes. Blah, 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 blah. Assume that the 16 sample values appear to be from a normally distributed population and construct a 98% confidence interval estimate of wait time for the population with Zipoclone treatments. All right, so we're asked to find the, I think they want us to create a confidence, there it is. They want us to create a confidence interval. All right, we need a confidence interval. All right, what am I looking for, ladies? What am I looking for? What am I looking for? I am looking for a part. I'm looking for CL, my sample size, sample mean, and my sample standard deviation, my S, because I told you they're all going to be S's. All right, what is your confidence level, ladies, for number 13? Anyone? What is your confidence level? Mine's pretty high right now. Probably because I have drugs. Well, for my allergies, but all right. Someone says 98. Bam! All right, 0.98. Very good. 0.98. What is your sample size? How many people were surveyed? Let's see. Very good. And we get that. Very good. 16. All right, now here's the tricky one. What's your sample mean? Is your sample mean the 102.8 or is it the 98.9? Dun, dun, dun. Which one would you choose? The 102 or the 98? That's a tricky one, right? No, not both of them. It's one or the other. All right, so let me give you a hint. The 102 was before the treatment, and the 98.9 was after the treatment. So which one are we more interested in? You want the wait time before they took the treatment of the Zipoclone, or do you want to know the results when they took the drug after it? Yeah, well, you want to do the one after it. So that's why we have to use the 98. We're not concerned about what their wait time was before the treatment. You want to know the results after they took the treatment. So that's why we want to do the 98.9. That was tricky, right? 98.9 is going to be the mean for the sample mean. And then your S is the 42.3. Right. So when you're conducting studies, you want to know the results after they took the medication or whatever, not before. We don't worry about the before. We already know they have problems with it, but we want to know if this drug is effective or not. That's why we have to use the 98.9. Make sense? All right, here we go. Let's plug it in like a Glade air freshener. Plug it in, plug it in. 98. I messed up. 98. 16. I'm going to put the 98.9 and the 42.3. I'm going to put it in the S. right? And make sure, and remember, but don't look what I did, okay? I just, because it's gonna happen to y'all. It's gonna happen to y'all where you type all this information in, but I have not hit evaluate. So don't put these numbers in there, right? The numbers that are appearing on the right side, they're from the previous problem. So make sure that you all hit evaluate. Hit it maybe like, I don't know, 10 times. I don't know. Hit it a couple of times just to make sure. Right. And now I have my results, and there it is. I'm gonna round it off to 3 places. So my answer is 71.379 mean and 126.421. That's the what is that? That's the minutes. We don't have to put the wait time minutes. Those are the wait time minutes. So the wait time minutes is between 71 and 126. So my question to you is this drug really helping the students or the people with insomnia? What do y'all think? It's saying that the drug is creating a wait time of 171 and 126. I don't think this is working. I don't think this drug is working. You know why? Because what was the wait time before the treatment? Do you remember what it was before the treatment? Before the treatment was the mean was, what was it? What was the mean before the treatment? It was 102, right? 102. Wow. So wouldn't you think that the drug would, yeah, it's 102. So is this drug really helping these people with insomnia? No, it looks like it's making it worse. Isn't that sad? That's sad. It's making it worse. Yeah, because 102.8 is it's in the middle. 102.8 is in somewhere in the middle. 102.8, it's in the middle. So if it was helping, this should have been my max right there. This should have been the max. That's too high. So no, it's not. This drug is not effective. Because the max is way above the time before drug use. Right? It's too, yeah, this number is way beyond that. So yeah, this drug is not, it's not effective. But there's something wrong, people, with the study. Who can identify, there's something wrong with it. There's something wrong with the study. Who can figure out why there's a problem with it? What's wrong with our study? Look how many people were sampled. 16. Is that really a good test to see if this drug is effective? No. Remember what we talked about before in our central limit theorem? What's the magic number? Isn't it supposed to be 30 or more? This number is too low. So this this calculation is not really determining whether this drug is effective or not because this number is too low. And it's got to be 30 or more. So there you go. There is your so do you want it, they wanted the confidence interval, which is that, and then they wanted you to compare it to see if the drug was effective or not. No, it's not, because this max is way above what it was before. So done. Questions or concerns? Again, you guys are just you're finding these 4 numbers, plug them in, let Statdisk calculate it for you, and boom, you're done. They're all gonna be like that, ladies. All of them. But again, you're gonna get confused. You're gonna say, well, how do I know whether I'm doing the sample, the mean, or the proportion? You got to look for this word, mean. If it says proportion, then you use the other formulas from 7.1. But 7.2 uses the term mean. Mean. You know what I mean? Mean. I need to shave my arms. But mean. Mean. Right? So cool. You guys asked some good questions. Those are perfect ones. So all of them, all the rest are going to be like that from 9 all the way through 27, I believe. They're all going to be like that. All of them. Okay. So that's how you handle finding the margin of error or confidence interval. You're gonna find these things. Okay. And of course, you have that other one. You're going to also be asked to find the sample size. So I'm going to show you now how to find the sample size. So here's part 2. Finding the sample size for a population mean. Okay. Oh, why is it? Oh, hello. I zoomed it in. Oh, sorry. All right. So on Statdisk, here's what you do. You're going to enter the CL, and I don't remember what else. I think you only have to enter 2 numbers, 2 or 3 numbers. I'm not too sure. I don't remember. What do I enter? Yeah, 3 numbers. Sorry, I knew it. All right, you're going to enter the CL, your margin of error. And you're going to enter the population standard deviation. Pop STD. Boom. You're going to enter those 3 numbers. Always. There's no if they don't give it to you or not. This is just straight. Find those 3 numbers, plug it in. Right. So you're going to find, let me switch it over. That's in the way. Oh, it's in the way. All right, so you're gonna find these 3 numbers. You guys gonna help me find those 3 numbers. Yeah. This one you may have a little difficulty finding, but I'll show you how to find it. It's simple. Simple. 2 more problems, ladies. 2 more problems, and then I'll let you loose. Loose. All right, too much, don't I? I'm sorry. I get excited. I don't know why. I just get excited. Okay, let's do on page 331. 331, we shall do, I guess we'll do 29. We'll do the one-term homework. Is that all right? Oh, I forgot to put the symbol. The O. All right, let's do 29. All right, so let's do 29. Let me look it up. 29. Stu Withers. All right, here we go. Freaking pollen. All right, here we go. What page is it on? 331, sorry. 331. All right, here we go. Mean IQ of college professors. The Wechsler IQ test is designed so that the mean is 100 and the standard deviation is 15 for the population of normal adults. Find the sample size necessary to estimate the mean IQ scores of college professors. We want a 99% confidence that the sample mean is within 4 IQ points of the true mean. The mean for this population is clearly greater than 100. The standard deviation for this population is less than 15 because it is a group with less variation than a group randomly selected from the general population. Therefore, if we use a sigma equals 15, we are being conservative by using a value that will make the sample size at least as large as necessary. Assume that sigma is 15 and determine the required sample size. Does the sample size appear to be practical? All right, ladies, what is your confidence level? We're doing sample size. What is your confidence level for this problem? Who can find it? Who can find it? Who can find it? Who can find it? It's a lot of words in this thing, right? Cool. Yeah, very good. 0.99. All right, all right. Now, let's see if you all can find the margin of error. Margin of error. Margin of error. All right, this one's a little bit difficult, right? Okay, let me give you a little hint. The margin of error is located with the term within, the number that's next to the word within. The within part is the indicator that that's the margin of error. Do y'all see it? Where is the word within? Bam, right there. Within. And your number is 4. So your margin of error is the number 4. So always, ladies, the magic keyword for the margin of error is the word within. Within. And then we already know what the O is. We know the population standard deviation. The O is obviously 15. So the hard part was the margin of error. Look for the word within, and you will see the number next to it. That is your margin of error. 15. All right, so I'm entering 0.99, the 4, and the 15. And voila. All right, so you're gonna go right here. You're gonna go to, all right, so where do I go on Statdisk? All right, so you're gonna go to on your notes, go to page, shoot, I can't see the freaking pages. Page 7 on your notes. Right. And okay, let me open it up on Statdisk. Analysis, sample size determination, estimate mean. And we enter the numbers. 0.99, a 4, a 15. Evaluate. My answer is the year that you guys were born in, 1994. Oh no, y'all weren't born in 1994. Y'all were born probably 2000. That's sick. Sample size is 94. The end. That's it. 94. All done. 0.99, the 4, the 15. Hit evaluate a couple times, maybe like 10, 15 times. And then presto. Questions? Should we do another one? One more, one for the road. One for the road. Hold on. I can't get my screen share to appear. Oh, there you go. Oh, hold on. Why does it do that for? There you go. Boom. Okay, one more. Okay, let's do. Yeah. I guess we'll do 31. How's that? 31, all right? Okay, let's do 31 then. Mean grade point average. Mean grade point average. Assume that all grade point averages are standardized on a scale between 0 and 4. Well, that's not how it works in high school. I already questioned that. Wow, how does someone get a grade point average above a 5, above a 4 in high school? It doesn't make sense. Their scale is stupid. Anyways, how many grade point averages must be obtained so that the sample mean is within 0.01 of the population mean? Assume that a 95% confidence level is desired. If we use the range rule of thumb, we can calculate O by the formula, range divided by 4. All right, so here's the thing. Sometimes they will not give you the O automatically. You're gonna have to use this formula, the range. How does the range work? You get the minimum, the max, the minus the minimum, the max minus the minimum. Here's your max is 4, right? Here's the 4. 4 minus 0. So they give you a like in between scale, 1, 0. You're gonna to calculate it, you do 4 minus 0 and then divide it by 4. You always divide it by 4. That's the formula for the standard deviation. It's the range divided by 4. So you do max minus minimum divided by 4 always. Hence, that's how they got the 1. You'll probably have to do the other ones the same, where you'll have to subtract that minus that. But anyways, so we're gonna give it to you. All right, so here we go. 31. What is your CL? your margin of error and your sigma. Yes, someone said that the margin of error was 0.95. What's your margin of error? Who can find it? Remember the keyword. Look for the word within. There it is, 0.01 right there. And we know our sigma, they already calculated it for us. It is 1. There it is. There's a 1. They figured it out for us. They showed us how they calculated, how they got the 1 by doing the max minus minimum divided by 4. All right, here we go. Plug it into Statdisk. 95.04, sorry, 0.01, 0.01, and then 1. Answer is a daily double. Sample size is, whoa, that's a huge number. 38,450. Oh, that's how much taxes I had to pay. 38,450. Bam. There's your CL. There's your margin of error. There's your standard deviation. Now, don't change your margin of error. Whatever margin of error number they gave you, just leave it as it is. Right? That's how it works. And there's my answer. Ta-da! Bam. Okay, so what are your impressions about chapter 7? Do you think 7 was much easier than 6? Would you be able to do like 7 like in a GIF if you had the notes, those handouts that I gave y'all? Would that help? Right. All right. So what I'm gonna do is I'm going to make your exam number 3. I'll post it tonight. And what I'm gonna put it in order. It's in order. The problems are in order. It goes from 6-1, 6-2, 6-4, 7-1, 7-2. It's all in order. I didn't mix them all at all. They're all in order. So when you get your test, what I want you to do is I want you to work backwards. Like start with number 24 and work your way down to number 1. That's my suggestion, okay? Because this stuff is fresh, right? The 7 is fresh. So work backwards. Start doing 24, 23, 22, 21, 21. Just work backwards. And then I'm going to put a video and I'm going to tell you on the video what each of those problems, what I'm going to reference the section where to locate in the book on those specific problems. Not only the book, but on your notes. I'm going to tell you, hey, problems from 1 through 4, go to this section. Problems 5 through something, go to this section. It's all, I'm gonna be real precise of what section to look for those particular problems. And you should be all right. Should be all right. If you do it that way, if you do work backwards, and you refer to that handouts that I gave you, the 6 and 7, right? Remember, you don't have to memorize where to round off. I provided all the rules where to round off on those handouts. So print them. Print them. If you make more copies, give them to friends or family. Give it to your abuelita or someone, you know. Give it to, I don't know. Give it to all the Karens out there, you know. You know what I'm talking about, all the Karens. All right, and we are done for today. Any questions? What does it say? Please stand by. I am getting a set. Bueno, muchachos, you all have a great day. Can you post a lecture video of? I didn't post it on there, Natalie. What? I didn't put it on there? No. Did I? Okay, I will. Will do. Will do, madam. Will do. From last week. Okay. Welcome. Bye, ladies. Have a good weekend. Oh, not have a good weekend. Have a good day. We'll see you on Wednesday. We're gonna start 8. Bye.